In this video, we're going to cover temperature conversions. Really, this is kind of just like a concept of thinking of how to make mathematical expressions from one unit to the other. So there's some basic information you need to start with this, and that's going to be the boiling point and the melting point / freezing point in these different scales. And we're just going to use water's boiling point and freezing point to get us started. So in degrees Celsius, those numbers are 0 degrees Celsius and 100 degrees Celsius. And for Fahrenheit, it's 32 degrees Celsius. I'm sorry, 32 degrees Fahrenheit and 212 degrees Fahrenheit for the boiling point and melting point, respectively. And basically what we're trying to do is trying to come up with a mathematical expression where if we're given something in degrees Celsius, we can convert that over to degrees Fahrenheit. Now, a lot of students tend to memorize this equation, but that's really not the scope of today's lesson. Today's lesson is to be able to figure out how to create a mathematical expression based on some information that you may already have. In this case, the information we already have is the substance water, but you could use any substance in order to do this. So ultimately what we want to do is we want to have our output of our equation to be in degrees Fahrenheit, and we want our input to be in degrees Celsius. So if I give you a certain temperature in degrees Celsius, what is that in degrees Fahrenheit? And to make these mathematical expressions, you need two things, okay? The first thing you need is a unit correction. And the other thing that you need is what we call a 0-point correction. And if I get both of these into my mathematical expression, I'll come up with a valid conversion factor from degrees Celsius to Fahrenheit. First thing that we're going to talk about is unit correction. So what we're going to do is we're going to do the delta, which means the change in between the boiling point and the melting / freezing point. So in degrees Fahrenheit, the delta between these 2 points, if I take 212 and I subtract 32, it comes out to be 180 degrees Fahrenheit. That's the difference between the melting point and the boiling point. If I do the same thing in degrees Celsius, the delta ends up being 100 degrees Celsius. That's the delta between these 2 points. Now I know these are equivalent. I know these are equivalent as well. And I look up their deltas, and with their deltas, I get a unit correction. What this means is for every 180 degrees Fahrenheit, there are 100 degrees Celsius, okay? And I know that as a fact, okay? So that's going to be our unit correction. 180 degrees Fahrenheit is equal to 100 degrees in Celsius, okay? And I'm going to put that unit correction in right here. Okay, so right here is going to be my unit correction. Since degrees Celsius is a numerator here, I want degrees Celsius to be in the denominator so that it'll cancel out. I also want degrees Fahrenheit to be in the numerator so that when I multiply my input by this unit correction, the degrees Celsius will cancel out, and then my output will be degrees Fahrenheit because that's what I want my output to be. And I said for every 180 degrees Fahrenheit, there are 100 degrees Celsius. 100 degrees Celsius. So right here takes care of the fact that a unit of Fahrenheit is not equivalent to a unit of Celsius. So I have my unit correction into my equation. The next thing I need to worry about is my 0-point correction. And the 0-point correction needs to be included in here because their starting points are not the same. Okay? As you can see, degrees Celsius starts at 0 degrees, and this is already at 32. So I just have to come into my equation and add 32, and that's going to be the 0-point correction. And now I have a valid mathematical expression that can convert degrees Celsius into degrees Fahrenheit. So I can pick any temperature here, okay, plug it into degrees Celsius, do the multiplication of the unit correction, and then add 32 to take care of the 0-point correction, and I'll get that conversion over into degrees Fahrenheit. Okay. One last piece here with this, with this equation here. This could be reduced because a lot of textbooks will have this 180 over 100. If I divide by 10, I'll get 18 over 10. But if I divide that by 2, I will get 9/5. So a lot of times you'll see this equation kind of written like this. And all that is this conversion factor simplified down to 9/5. Same equation though. Okay. Now, if we wanted to add one more scale, like the Kelvin scale, and I included the boiling point and the melting point, which is going to be 373 Kelvin and 273 Kelvin respectively, I can do the same thing. Let's try to get an equation for Kelvin, which would be our output, and degrees Celsius as our input still. We would want to put a unit correction right here, and then we'll want to put a 0-point correction right here. So let's take a look at the delta for Kelvin. Okay, so if I take the delta in Kelvin, the difference between 373 and 273 is 100 Kelvin. That's interesting. This is kind of saying that for every 100 units of Celsius I have 100 units of Kelvin, which tells you their units are exactly the same. Okay, as one goes up 1 degree, the other one goes up 1 as well. 100 to 100 is a 1-to-1 conversion. Okay, but we can still put that for every 100 degrees Celsius, we have 100 Kelvin, just like what we did before. Okay, same thing is true though with Kelvin as it was Fahrenheit. The starting point's not the same. Celsius is starting at 0. This one's starting at 32, so we added the 32. This one is starting at 273, so we got to add 273. So right here is the unit correction, and right here is the 0-point correction. So really, if we want to get into Kelvin, all we have to do is take our degrees Celsius. Since this number is 1, really all we have to do is add 273, and we have a conversion factor from Celsius into Kelvin. Of course, both these equations can be rearranged and flipped around to figure out, how many Celsius would be if our given was Fahrenheit, or what would our Celsius be if we were given Kelvin. You just have to do some basic math in order to figure out those equations. But that's the kind of like the exercise today. It's not kind of memorizing this equation or this equation or this equation. It's to use boiling points and melting points to come up with mathematical expressions and equations to figure that out instead of memorizing.